Today we're going to be introducing the concept of acids and bases. We're going to go through a couple of definitions for acids and bases, but first we'll start with the one created by the guy in the picture on the left. Svante Arrhenius lived at the end of the 19th century and then into the 20th century, and he came up with his definitions of what he would define as an acid and a base. So for him, an Arrhenius acid is any chemical compound that increases the concentration of hydrogen ions in an aqueous solution. So when we look at hydrochloric acid, which we know is an acid, it's in the name, when it breaks apart, we get a hydrogen ion and a chlorine ion. Notice that hydrogen is positive, that chlorine is negative, because that hydrogen has donated its electron to chlorine. When we're looking at that, we know that hydrogen, just a stable hydrogen that we see on the periodic table, it has one proton and one electron. That makes it neutral. Notice when it has given away that electron, it no longer has any electrons. It is just a proton. So sometimes you'll see it as a proton. That's what they'll call hydrogen ions. That's where they get that. Notice when we have hydrochloric acid in water, it looks a little bit different. So we have our hydrochloric acid, and it's aqueous, and we have water, which is liquid, since that's pure water. Now when we mix those together, that hydrogen from our hydrochloric acid will attach to water, and then that chlorine will be by itself. So we're not actually increasing the concentration of hydrogen ions in aqueous solution. If you look at it technically, we're actually increasing the concentration of something called hydronium, that H3O+. So I've actually put in a picture here to break it down for you. If you look on the left, when it's hydrochloric acid, it is sharing that electron, those electron pairs between hydrogen and chlorine. But when it breaks apart, that hydrogen, which is now again just a proton, it no longer has its electron, has attached to H2O to form this H3O+. Notice it has a positive charge because that basically accepted a proton. It just accepted that proton. Protons are positive, so it becomes positive. And then that chlorine has taken away that electron, so it is now negative. So that's what he meant by an Arrhenius acid. That is his definition. Notice we also have something called an Arrhenius base, of course, and that is any substance that increases the concentration of hydroxide ions in an aqueous solution. Remember that hydroxide ions just means OH minus. So if we're looking at sodium hydroxide, notice when that breaks apart, we get sodium, which is positive. We know that from the periodic table, it wants a +1 charge, so it can look like those noble gases and be more stable. So hydroxide, to balance that out, will have a -1 charge. And think about it, if you have water, it has a neutral charge. If you remove that hydrogen, that positive hydrogen, it now becomes -1 negative. That's what hydroxide is just that -1. Remember from our previous lessons where we talked about some of your strong acids? Remember our mnemonic to help us remember it? We have that CSI on NBC. So hydrochloric acid, H2SO4, HI, HNO3, HBr, and then HClO3 and HClO4. So I recommend writing this down. That'll help you remember the ones that are typically called strong acids. And then anything else that is not a strong acid, but is still an acid, would just be a weak acid. For our strong bases, generally that's our first row of the periodic table plus those hydroxides. So sodium hydroxide, potassium hydroxide, things of that nature. And then of course if it's not a strong base, but it's still a base, then it is a weak base. So I recommend writing down some of these definitions, kind of learn what it means to be an Arrhenius acid or an Arrhenius base, because your next video will be about a different definition for acids and bases.